Okay, question number 12. A set of data consists of 3, 6, 10, 12, and 15. So let me write down all the data. So we have 3, 6, 10, 12, and 15, whereby the number of data is 1, 2, 3, 4, 5. So n equals to 5. Huh? So what are we supposed to do next? Find the mean and standard deviation of the set of data. In this case, we just use the formula. Okay, let's find the mean first. X bar equals to the total x divided by n. Alright, so 3 plus 6 plus 10 plus 12 plus 15 divided by 5. Now this one, the next step, you just get the data, key in your calculator, and get the answer. Okay, so over here we will have 3 plus 6 plus 10 plus 12 plus 15. 15, double check. 3 plus 6 plus 10 plus 12 plus 15. Okay, and then divided by 5, or 9.2. We have 9.2 as our answer. So 9.2 is the mean. And don't forget the standard deviation. Standard deviation basically is the x squared, sum of x squared divided by n minus the square of our mean. So in this case, well, we just use the calculator. So we have 3 squared plus 6 squared plus 10 squared plus 12 squared plus 15 squared over 5, and then minus 9.2 squared. Now, this question, 1 mark for this, 1 mark for this. Actually, the working we just show. Then the detail we don't need to show. In fact, we can use the calculator to key in the formula and let the calculator calculate for us. Okay, what do I mean? Basically, we can use the function of the calculator. Let's clear everything first. Shift mode or, so that we can clear, reset everything. No memory is in the calculator. Then we go to mode. We go to SD. That is to calculate the data. So key in the data like 3, right? So key in the 3. Alright, since each data only appear once, so we can just straight away key in 3 and then n plus. Okay, then the next one, you see n equals to 1, that means we just key in 1 data. So 6, the next one is 6, then n plus. Okay, so now we have 2 data in our memory. So the next one is 10, n plus. Okay, 12, n plus. 15, n plus. N plus means the total memory. Next, we want to call our function of standard deviation. We will go to, you see your number over here. Do you see the key of 1 and the 2? The 1 is sum, the 2 is the variation. So let's press this button, shift, because the function is in the orange wording. So we want to call the orange word out. So we shift and then we press the variance. You want to press variance also can, sum also can. Let's press the variance, see what do we have. So under the variance, you will see this, the x bar, which is the mean. You can get the mean right away. Let's check our mean. Number 1, enter. See, 9.2. What about, check again, shift number 2. The standard deviation, press number 2. And that is our standard deviation, 4.2614. So let's write this 4.2614 as our answer. Okay, 4.2614. 4.2614. Okay, I think I forgot something. This is the standard deviation. Don't forget that it's a square root. If without the square root, that will be the variance. Let's check whether this is the correct answer or not. Okay, so let's go back to the normal computation. So we have 3 squared plus 6 squared. I just want to show you 3 squared. So next time you just use the function right way. 3 squared plus 6 squared plus 10 squared plus 12 squared plus 15 squared, and then total, and then divided by 5, and then minus 9.2 squared equals 2, and then we square root this one, 18.16. You see, our answer is 4.2614. So what is important is you show the correct formula. The next one, you just give the answer right away. Okay? Because we want to see whether you substitute everything correctly or not. Okay? This is the answer. Alright, so we have done the part A only. That is the mean and the standard deviation of the set of the data. Next, we need to find the new standard deviation if each of the set of data is added by 5. Everything is increased by 5. Everything is increased by 5. So that means the new data is where the original data increased by 5. Therefore, your mean, mode, median, standard deviation will also increase by 5 when you have when you add something. Your mean, mode, median will increase by 5, but your standard deviation, your mode, will still remain unchanged. So the new standard deviation will still equals to 4.2614. That's it. Nothing changes unless you are multiplying something. Otherwise, when you have add or minus anything, no changes to our variance, no changes to our all the central of the measure of dispersion will have no effect on any addition and subtraction.